This video is about maximizing the area of a rectangular field. So let's take a look at what the problem says, that you need to enclose a rectangular field with a fence. You have 600 feet of fencing to cover 3 sides of the field. What are the dimensions of the field that will produce the largest possible area? All right, so let's begin by writing out all the information that we know and drawing a picture of the situation so we have a better idea on how to solve this. So we know that the field is rectangular and that we only really care about 3 out of the 4 sides of our rectangular field. So this side on top doesn't really matter that much to us. So I'm going to label this X because I don't know how big that side is, and if this side is X in a rectangle, this has to also be X. And so this side I'm going to call Y. I know that the area of any rectangular shape is always going to be the base times the height, or the length multiplied by the width, so it's X times Y. And I also know that the amount of fencing that I have is 600 feet. So that's all I have to cover all 3 of these sides right here. I've got 600 feet. So I can say that it's equal to 2 X's plus 1 Y. Okay, so again, this is all my information that I have at this point in time. So if you see right here, I have multiple variables. I've got X, I've got Y, and I've got A. So I'm going to take my equation that only has 2 variables in it because it's less complicated, and I'm going to isolate a variable in this equation so I have something easier to deal with. All right, so if 600 equals 2x plus y, all I have to do is isolate one of my variables, and the easiest one to get by itself is y. To do that, I can just subtract the 2x from both sides, and I end up getting 600 minus 2x equals y. So now, since my area formula is x times y, right here, I can say that by substitution, area equals x multiplied by 600 minus 2x. All right, so that means that my area in terms of x, so I'm going to write this in function notation, is equal to, just distribute that x through, you end up getting 600x minus 2x squared. So I'm going to add that in to my list of information that I know. Now that I've figured out my equation for the area of the rectangular field, I need to figure out, well, what values of x will even satisfy this equation at this point in time? What's the smallest x that could work? What's the largest x value that can work? Well, in order for this to have a rectangular field right here, the x value has to be bigger than 0. It can't go below 0. So I know for a fact that the smallest value I could have for x is slightly above 0. Okay, but what's the largest value that I could have for x? Well, here, the smallest value of y that I could have is also slightly above 0. So I need to know what's the upper limit for my x value. So what I'm going to do is I'm going to use the equation that we use to figure out how to find the fencing, because that's really what's giving me my limit. I have a limited amount of fencing, and I want my fencing to not go above 600. So that means that 600 has to be greater than or equal to this 2x plus y right here, okay? And the smallest value of y that we could possibly have would be slightly above 0. So now 600 has to be bigger than 2x plus 0. And the reason why I dropped this equal to right here is because y can't technically be 0, otherwise this wouldn't be a rectangle anymore. It would just be 2 lines that are not connected at all. So if y can't be exactly equal to 0, then this means that x can't be equal to 600 right here. Okay, so then I get 600 is bigger than 2x, which means that 300 is greater than x. So now we've got our lower limit. X is greater than 0, but less than 300. Now we can go ahead and use our equation for the area, and this is really where the optimization begins. So remember, when you take the derivative of any function, it will give you a local minimum or a local maximum, okay? Let's find out what the derivative of this function is. So I'm going to do a prime of x equals. Now remember, when you take the derivative of any function, you take your exponent, you multiply it by your coefficient, and then you subtract 1 from this exponent. So 1 multiplied by 600 is 600, and the x to the first power becomes x to the 0th power, and x to the 0th power is 1, so I don't have to write anything down because 600 multiplied by 1 is 600, okay? And then, same thing with this term right here. The exponent on this x is a 2, so multiply 2 by the coefficient of -2, you get -4x to the first power because you subtract 1 from this exponent. So now we know our derivative. Now remember, when you're finding the derivative, it will tell you the slope of any function at any point. So what I'm looking for is the highest point of my function. So I want my slope right here to be equal to 0. Okay, so in order to do that, I set my derivative equal to 0. So if a prime of x equals 600 minus 4x, set it equal to 0, you get 600 minus 4x, solve by adding 4x to both sides, and dividing by 4, you end up getting x equals 150. So now we know that we have a local maximum at x equals 150. And we know it's a maximum because we know that our parabola, our quadratic function, which is modeled by this equation right here, will have a graph that opens downward. So we know that this point right here represents a maximum as opposed to a minimum. So remember, we're trying to find the value of x, or the dimensions that will give me the largest possible area. And we know that the local maximum will occur when x is 150. But we still have to check our endpoints because this is a local maximum and not an absolute maximum. So I need to figure out a of 0, a of 300, and a of 150 using the equation that we already figured out, which we have right here. So if I want to figure out what a of 0 is, I just replace x with 0. So 600 multiplied by 0 minus 2 times 0 squared. So that means that a of 0 is equal to 0, okay? And then if I do the same thing for a of 300, so we checked our lowest value, a of 300, every time I see an x, I'm going to replace it with 300. So it becomes 600 multiplied by 300 minus 2 times 300 squared, okay? Once you do all the arithmetic for this, you end up getting a of 300 is equal to 0. So we tested our largest value, and now we have to test our local maximum. So I'm going to figure out what a of 150 is by plugging in 150 every time I see an x. So I'm going to do 600 multiplied by 150 minus 2 times 150 squared. So that means that when you do all of this arithmetic, you end up getting a of 150 is equal to 45,000 square feet, which is going to give us the largest possible value because that's larger than 0. We don't want our area to be 0 at all, and we figured out that our largest value will either happen here or at 0 or at 300. So remember, we want to figure out the dimensions of our rectangle, so we have to solve for x and for y, and we already know that x has to be 150 feet. So I'm going to use this equation, 600 equals 2x plus y, to determine what the value of y is going to be. So replace the x with the 150 that we got before, and then solve for y, so you end up getting 600 equals 300 plus y, which means that y equals 300 feet. So the dimensions that will maximize your area are 150 feet by 300 feet, and we are done.